4 structures, built without modern engineering. A wall of 100-ton stones that no earthquake has ever brought down. 11 meters of granite stacked without a drop of mortar. A fortress laid out as a perfect circle 1,000 years ago. And a warship that sank in 20 minutes and came back 3 centuries later. All 4, back to back. Above the city of Cusco, in the Peruvian Andes, there is a wall built from stones weighing more than 100 tons each. They are not rectangular. They are irregular, many-sided shapes, and each one has been cut to fit its specific neighbors so tightly that you cannot slide a sheet of paper into the joint. There is no mortar anywhere in it. And in the earthquakes that flattened the Spanish city built beside it, this wall did not fall. It is called Sacsayhuaman. It was built by the Inca in the 15th century. And the reason it survives is not a mystery. It is a set of very deliberate engineering decisions made by people who understood exactly what the ground under them was going to do. First, where we are. Cusco was the capital of the Inca Empire, the largest state in the pre-Columbian Americas, running down the spine of South America. Sacsayhuaman sits on high ground above it, and it is enormous. 3 terraced walls in a long zigzag, running for hundreds of meters, stepped one above the other. The stones are the first thing anyone notices. The largest blocks in the lower terrace are usually cited at over 100 tons, with some estimates going considerably higher. For comparison, a fully loaded articulated lorry is around 40. These are single pieces of rock several times that, standing in a wall on a mountainside. The second thing you notice is the shape. This is polygonal masonry. Rather than cutting every stone into the same rectangular brick, the Inca fitted stones of wildly different shapes and sizes together. 5 sides, 6 sides, 12 sides. Each one dressed to match the specific stones already in place around it. The joints run in irregular jigsaw lines, and they are extremely tight. And this is the point where a certain kind of video usually tells you it is impossible, that nobody knows how it was done, and that the answer must be a lost civilization or visitors from somewhere else. So let us be clear about that, because it is worth saying plainly. There is no mystery about who built Sacsayhuaman. The Inca did. It is documented. Spanish chroniclers who arrived within a generation, including Pedro Cieza de León, described the construction and the enormous workforces hauling stone across the mountains with ropes. The methods were not exotic either. Quarrying by working natural fractures in the rock. Moving blocks with ramps, levers, log rollers, ropes, and very large numbers of coordinated people. Shaping stones with harder hammerstones, pounding rather than carving. And crucially, fitting by repetition. Lower a block, see where it touches. Lift it, dress down the high spots, lower it again. Repeat until it seats. It is slow, and it is laborious, and it is completely achievable. Calling it impossible is not a compliment to the Inca. It is a way of taking the credit away from them. Which brings us to the real question, and it is a better one. Not how did they lift the stones, but why build this way at all? Because polygonal masonry is much harder than cutting standard blocks. Every stone is bespoke. You cannot mass produce it, and you cannot easily replace a piece. If you just wanted a wall, this is the least efficient way to get one. The answer is under your feet. Peru sits on one of the most seismically active zones on Earth, where the Nazca Plate grinds beneath the South American plate. That collision built the Andes, and it also means that anything constructed there will, sooner or later, be shaken hard. So consider what an earthquake actually does to a wall. It shakes the ground horizontally, and the wall has to absorb that energy. A rigid wall, mortared, brittle, all one piece, has very few options. The stresses concentrate at its weakest points, cracks open, the wall loses integrity, and it comes down. Now look at what the Inca built instead. The first decision is the inward lean. The walls are not vertical, they batter backwards as they rise, so the structure's own weight is directed down and into the slope rather than outward into thin air. A leaning-in wall is much harder to push over than a plumb one. The second decision is the absence of mortar. And this is the counterintuitive part. Mortar sounds like strength. In an earthquake, it is often a liability because it makes the wall a single rigid object that can only crack. Without it, each stone is a separate piece that can shift a fraction of a millimeter, absorb some energy, and settle again. The wall behaves less like a slab and more like something flexible held together by weight. The third decision is the polygonal fit, and it is what makes the second one safe. If you build a dry stone wall out of neat rectangular blocks, everything lines up, and continuous straight joints are exactly where a wall shears apart under sideways load. Irregular, many-sided stones do the opposite. The joints zigzag. Each stone is keyed into several others above, below, and beside it, so a block cannot simply slide out. The wall is interlocked in every direction at once. Put those three together and you get a structure that does not resist an earthquake by being rigid. It survives one by moving slightly, then putting itself back. The stones lift and resettle, and the geometry returns them to where they were. And there is a real-world test of this, run twice. Major earthquakes struck Cusco in 1650 and again in 1950. Both caused severe damage to the Spanish colonial city. Churches and buildings collapsed. The Inca walls beneath and around them largely did not. In parts of Cusco today, you can see the result directly, an original Inca wall still standing, with later construction sitting on top of it, and it is the later work that has had to be rebuilt. There is one more thing that explains what you see at Sacsayhuaman today, and it is not an earthquake. After the Spanish took Cusco and put down Manco Inca's rebellion, they began pulling the complex apart and using it as a quarry, carting off the cut stone to build colonial Cusco, which is why the site looks the way it does. The upper structures are largely gone. What remains is the lower terracing, the blocks that were simply too big to be worth moving. The surviving walls are not what the Inca considered the whole building. They are the part nobody could carry away. So what is Sacsayhuaman actually? It is a stone wall built by people without iron tools, without wheeled transport, without draft animals capable of the work, and without written mathematics as we would recognize it, who nevertheless produced a structure so well matched to its own ground that it has outlasted by centuries the buildings raised by the empire that dismantled it. That is a far more interesting story than the one where somebody magic did it. And it leaves a question that is genuinely uncomfortable for us. We are surrounded by buildings designed to last a few decades before replacement. The Inca built something that has now stood through 500 years of earthquakes without maintenance. So which of the two of us is actually the advanced one? In southern Africa, there is a wall 11 meters high and 6 meters thick, curving for about 250 meters. It is built from shaped granite blocks stacked without a single drop of mortar. Nothing glues it together. It has been standing for roughly 600 years. And for most of the 20th century, the people who governed that land insisted it could not possibly have been built by Africans. It is called Great Zimbabwe. It is the largest ancient structure in sub-Saharan Africa. This is how it was built, and the story of the lie that was told about it for almost 100 years. Great Zimbabwe was a city, not a fort, not a temple on its own, but a working capital, occupied roughly between the 11th and 15th centuries. At its height, it was the center of a state that controlled trade across a large part of southern Africa, connected outward to the Indian Ocean world. The name itself tells you what the builders were doing. Zimbabwe comes from a Shona phrase understood to mean houses of stone. And that is the distinguishing choice. Across most of the region, people built with timber, clay, and thatch. Good, practical materials for the climate. At Great Zimbabwe, the people in charge chose stone. And they chose it at a scale nobody around them was attempting. The material was already there. The landscape is granite, and granite in that region naturally exfoliates. Heat and cold cause the outer layers of exposed rock to split off in sheets. which means the raw material for building arrives partly prepared. You still have to work it, but nature has given you a head start on flat, block-shaped pieces. The most famous part of the site is the Great Enclosure, a curving outer wall, up to about 11 meters tall, up to 6 meters thick at the base, running roughly 250 meters around. Inside it, another wall runs parallel to part of the outer one, forming a narrow passage, and at the end of that passage stands a solid conical tower built of the same stacked stone, with no door and no interior. It is not a granary and it is not a tomb. It is generally understood as a symbolic structure, most likely a statement about the authority of whoever ruled here. Now, the engineering. Because the thing that makes those walls remarkable is what is not in them. There is no mortar, no cement, no clay binder, nothing. Every block is held in place by its own weight and by how precisely it sits against its neighbors. This is dry stone construction, and at 11 meters it is not a casual technique. Two decisions do most of the work. The first is the stone itself. The blocks are shaped and sorted so that each course sits level and stable, rather than rocking on a high point. The second is the shape of the wall as a whole. Each layer is set very slightly further back than the one beneath it, so the wall leans gently inward as it rises and thins as it goes up, thick and heavy at the base, lighter at the top. That inward lean is the trick. It directs the wall's weight down and inward into itself rather than pushing outward, which is the direction a wall fails in. A mortared wall resists collapse by sticking together. A dry stone wall like this resists collapse by being shaped so that gravity holds it closed. It is a structure that is stable because of its geometry, not because of its glue. And because there is nothing rigid bonding the stones, small movements in the ground get absorbed instead of cracking the wall apart. By around the 15th century, Great Zimbabwe declined as a center of power. The likeliest explanations are practical. A very large population in one place puts pressure on farmland, grazing, water, and firewood, and trade routes shift over time. Power moved elsewhere. The city emptied. The walls stayed. And then, in the late 19th century, Europeans arrived in the region in force. And the second half of this story begins. Because when colonists encountered a monumental stone city in the middle of southern Africa, a great many of them refused to accept the obvious conclusion about who had built it. So alternatives were invented. It was said to be Phoenician, or Arabian, or the work of the biblical Queen of Sheba. Anything, so long as the builders came from somewhere else. And it is worth being precise about why. These were not conclusions drawn from evidence and later overturned by better evidence. They were assertions that started from the belief that local African societies could not have done it, and then went looking for a builder who fitted. This was not a fringe view. Under colonial administration, and later under white minority rule in Rhodesia, the foreign origin story was the official framing. The site was excavated in ways that damaged the archaeological layers. Treasure hunting more than excavation, destroying exactly the evidence that could answer the question. And when professional archaeologists did the work properly and concluded that the builders were local, that conclusion was politically inconvenient enough that it was discouraged and downplayed. The evidence, however, was never actually ambiguous. Pottery, building traditions, settlement patterns, layout, artifacts, linguistic and cultural continuity, all of it ties Great Zimbabwe to the ancestors of today's Shona communities. That is not one theory among several. It is the archaeological consensus, and it has been for a long time. The outside builder claims are the ones that failed. Today, the site is a UNESCO World Heritage Site, and the dry stone walls still need what they always needed: people who know the technique. Because there is no mortar to repair, conservation means understanding how the stones are meant to sit and rebuilding sections correctly, a craft that has to be taught, not just documented. And the country around it settled the argument in the most direct way available. When Rhodesia became independent in 1980, the new nation took its name from the site, Zimbabwe. Carved soapstone birds recovered from the ruins, the Zimbabwe bird, became the national emblem and appear on the flag. So what is Great Zimbabwe? Structurally, it is a masterclass in doing a great deal with very little. No mortar, no arches, no imported technology, just granite, geometry, and an enormous amount of skilled, organized labor. Historically, it is something less comfortable. It is a building that spent a century being used as evidence for a claim it flatly contradicted. Which is the part worth sitting with. The walls never changed. The stones never moved. Everything that was wrong about the story was in the people looking at it. So the question Great Zimbabwe leaves behind is not really about who built it. That was answered a long time ago. It is this: how much of what we currently believe about the past is actually about the past, and how much of it is about us? Around the year 980, somewhere in Denmark, a group of people did something that does not fit what most of us think we know about Vikings. They laid out a fortress as a perfect circle, not roughly round. A circle, with 4 gates placed exactly at north, south, east, and west. Then they built several more, to the same design, in different parts of the country. And then, within about 20 years, they walked away from all of them. They are called the ring fortresses, and the best preserved of them is Trelleborg, on the island of Zealand. This is the story of one of the most disciplined construction projects of early medieval Europe, and why nobody is completely sure what it was for. Start with what a fortress normally looked like in this period. If you needed a stronghold, you found a hill, or a bend in a river, or a spit of land between 2 waterways, and you built defenses that followed the shape of the ground. The terrain did most of the design work for you. It is cheap, it is sensible, and it is what almost everybody did. The ring fortresses do the opposite. They impose a shape on the land. Each one is a circular earth rampart with a V-shaped dry ditch outside it, and 4 gateways cut through the ring at the 4 cardinal points. Inside, 2 streets run between those gates and cross in the middle, dividing the interior into 4 equal quadrants. And inside each quadrant, the same thing again. Long boat-shaped halls arranged in squares around a courtyard. The same building, repeated to the same plan. This is not a settlement that grew. It is a design that was drawn and then executed. Which raises a question that archaeologists find genuinely interesting. How do you lay out a large, accurate circle on open ground with the gates squared to the compass before anything like modern surveying exists? You need a fixed center, a way of keeping a constant radius, and a way of finding true directions. None of that is magic. A rope, a peg, and the sun will get you a long way, but all of it requires somebody who knows what they are doing, and a crew willing to follow instructions exactly. And the fortresses were not one-offs. Trelleborg on Zealand, Furkat and Aggersborg in Jutland, Nonnebakken on Funen, and Borgring, which was only confirmed relatively recently. Different places, different landscapes, the same idea. Archaeologists studying the measurements think a standard unit of length was used across the sites, possibly the Roman foot. That is an inference from the stones and soil rather than something written down, so treat it carefully. But the implication is striking. Somebody was working to a specification. Which brings us to the person usually credited with them, Harald Bluetooth, King of Denmark. Yes, the same Harald whose initials ended up on the Bluetooth logo 1,000 years later. Because the technology was meant to unite different devices the way he united different territories. Harald's reign is the moment Denmark starts behaving like a state rather than a collection of powerful families. He claimed, on a rune stone at Jelling, to have won all of Denmark and Norway and made the Danes Christian. Whether that claim is entirely true is a separate argument. But a ruler making that kind of statement needs to be able to do things that ordinary chieftains cannot. And building 5 identical geometric fortresses across your kingdom, quickly, is exactly that kind of thing. So what were they actually for? This is where the honest answer is that we do not fully know, and the explanations pull in different directions. The first reading is military. They are usually dated to around 980, and one interpretation is that they were thrown up in response to a real external threat, pressure from the Holy Roman Empire to the south. Under that reading, these are garrisons, places to hold troops, ready. The second reading is political, and it is about the inside rather than the outside. A fortress that, identical in 5 separate regions, is a message to the people living around it. It says the king can put a permanent uniform installation in your district whether you like it or not. On that reading, the circles are less about foreign armies and more about domestic control. Royal power made visible in earth and timber. The third reading is logistical, bases for gathering, supplying, and launching expeditions, somewhere to assemble people and goods under royal authority before moving them somewhere else. These are not mutually exclusive, and different archaeologists weight them differently. What is not in dispute is the cost. Building even one of these means moving an enormous volume of earth by hand, felling and shaping a very large quantity of timber, and feeding and organizing the workforce that does it. Through a season, in a society without money in the modern sense, without wheeled cranes, without written contracts. Multiply that by 5, and then there is the part that makes the whole thing strange. They were used for roughly 20 years, around a generation, and in some cases less. Then they were abandoned. The threat, whatever it was, passed. The political situation changed. Harold's own reign ended in conflict with his son, and the fortresses simply stopped being worth what they cost to hold. So what is left? Not walls. These were earth and wood, not stone. And wood does not last 1,000 years in Danish soil. What survives is the shape. At Trelleborg, you can still walk the rampart and see the ring, the gaps where the 4 gates were, and the outlines of the halls marked out on the grass. It reads less like a ruin and more like a diagram, drawn at full size, in a field. For a long time, that was a fairly local story. Then, in 2023, Trelleborg, Aggersborg, Nonnebakken, and Borgring were added together to the UNESCO World Heritage List, recognized not as 5 separate ruins, but as one connected system, the physical evidence of a kingdom being assembled. And that is what makes them worth a look. The popular image of this period is longships and raiding, motion, opportunism, chaos. The ring fortresses are the opposite of that image. They are planning, standardization, a shape held to across an entire country by people who never saw each other's work. That is not the behavior of a raiding party. It is the behavior of an administration. Which leaves a genuinely open question. We are looking at one of the most organized construction efforts of its time and place, and we still cannot say with certainty what it was meant to achieve. Only that, whatever it was, it stopped mattering within about 20 years. So, when a society spends that much of itself on something that precise, and then lets it go that quickly, what does the building actually tell us? That the plan failed? Or that it worked so completely it was no longer needed? On the 10th of August, 1628, the most expensive object in Sweden sailed out of Stockholm harbor. Thousands of people had come to watch. Foreign diplomats, families, sailors' wives. It was the largest, most heavily armed, most beautiful warship the country had ever built. It traveled about 1,100 meters. Then it rolled over and sank, in front of all of them. The ship was called the Vasa, and it was never supposed to be a cautionary tale. It was supposed to be the thing that made Sweden untouchable at sea. This is how a nation built the finest warship of its age, and why it lasted about 20 minutes. To understand the Vasa, you have to understand what Sweden was in the 1620s. It was a rising military power, fighting its way into the 30 Years' War, a conflict that would eventually kill millions across Europe. Its king, Gustavus Adolphus, needed a navy that could dominate the Baltic. And he wanted ships that announced it. So the order went out for something extraordinary. A warship with not 1 but 2 full decks of heavy bronze cannon, stacked one above the other. At the time, that was rare, expensive, and genuinely intimidating. Bronze guns cost a fortune. Putting 64 of them on a single hull was a statement about how much Sweden was willing to spend to win. And then there was the decoration. The Vasa was covered in carvings, hundreds of them. Lions, Roman emperors, biblical figures, sea creatures, warriors, all carved in oak and pine, painted in bright colors and covered in gold leaf. This was not decoration for its own sake. In the 1600s, a warship was a floating advertisement for the power of the king who owned it. When the Vasa sailed into a foreign harbor, the message was supposed to arrive before the ship did. Building it took years and consumed enormous resources. Around 1,000 oak trees went into the hull. Hundreds of workers, shipwrights, carvers, painters, ropemakers, blacksmiths were involved. By the time it was finished, the Vasa was roughly 69 meters from the tip of the bowsprit to the stern, with a main mast rising over 50 meters above the waterline. It was, by any measure of the era, a triumph. And it was already in trouble before it ever left the dock. The problem was invisible, and it was simple. The Vasa was too heavy at the top and too light at the bottom. In the 17th century, nobody could calculate this. There was no naval architecture in the modern sense. There were no stability equations, no formulas for center of gravity. Ships were built from experience, from rules of thumb, from what had worked before. And nothing quite like the Vasa had been built before. The shipwrights were in effect guessing, and the ship they were guessing at was heavier and taller than anything in their experience. There is also a detail that has been passed down in the accounts of the disaster, and it is remarkable. Before the maiden voyage, the ship was given a stability test. 30 men ran back and forth across the deck to see how much it would rock. They managed 3 passes before the ship was heeling so badly that the test was stopped for fear of capsizing the vessel at the quayside. The Vasa sailed anyway. So, what actually happened on the 10th of August? The failure came from 3 directions at once. The first was the ballast. To stay upright, a tall ship needs weight low in the hull, stone, usually, to counteract the weight of masts, rigging, and guns above. The Vasa carried ballast. It simply did not carry enough for a hull carrying 2 gun decks and that much timber and gold above the waterline. And here is the cruel part. There was not enough room to add more. The lower gun deck sat too low in the ship. Piling in more stone would have pushed the gun ports closer to the water, which was the exact thing that killed it. The second was the shape of the hull itself. Modern studies of the wreck have found that the ship was not perfectly symmetrical. Evidence suggests different work crews used different measurement systems, one based on Swedish feet, another on Amsterdam feet, which differ in length. A hull built from 2 slightly different rulers is a hull that does not sit evenly in the water. That claim comes from analysis of the recovered timbers, not from a document signed in 1628. So treat it as the best available explanation rather than a confession. The third was the weather, and it was not even dramatic. The Vasa left the harbor under light wind. It was towed along the waterfront, and then a handful of sails were set. A modest gust came down over the hills of Stockholm and pushed the ship over to port. It came back up. Then a second gust arrived, and the ship leaned further and did not come back. Water began pouring in through the open lower gun ports. And they were open because this was a ceremonial departure. The crew had fired a salute. Once the sea found those openings, the outcome was fixed. The Vasa filled, rolled, and went down in about 32 meters of water, roughly 120 meters from shore. Of the estimated 150 people aboard, around 30 drowned. Some had families with them. On a first short passage, it was not unusual to bring relatives along. There was an inquiry. The surviving officers were questioned. The shipbuilders were questioned. And the record of it is almost uncomfortable to read, because everyone involved was standing very close to a truth nobody could say out loud. The ship's design had been approved by the king. The proportions had been signed off. To blame the design was to blame the crown. In the end, according to the surviving accounts, nobody was punished. The verdict was, essentially, that it was God's will. And that should have been the end of it. A humiliating loss, a few salvaged cannons, and a wreck forgotten in the mud of a busy harbor. Which is, more or less, what happened. For 333 years, the Vasa sat on the bottom of Stockholm's harbor while the city grew up around it. But the Baltic Sea is unusual. It is cold, it is low in oxygen, and it is far less salty than the open ocean. The shipworm that devours wooden wrecks in most of the world cannot survive there. So the Vasa did not rot away. It waited. In 1956, a researcher searching old records and probing the seabed found it. In 1961, after years of preparation, cables were run beneath the hull and the Vasa was lifted, essentially whole, back into the daylight. Most of the ship you can see today is the original 17th century timber, not a reconstruction. The actual wood, cut before the invention of the steam engine, the light bulb, or the United States. It now sits in a purpose-built museum in Stockholm, where the air is temperature and humidity controlled to keep it from drying out and collapsing under its own weight. Between its recovery and the start of 2025, more than 45 million people have walked in to look at it. It is one of the most visited museums in Scandinavia. Which leaves a strange conclusion. The Vasa failed at literally the only job it was built to do. It never fired a shot in war. It never frightened an enemy fleet. As a warship, it is arguably the worst investment in Swedish naval history. And yet, it is the only ship of its era that anyone outside a university has heard of, seen with their own eyes, or stood underneath. Every ship that worked is gone. This one is here because it failed early enough to be preserved. So what does that make it? A disaster? Or the most successful shipwreck ever built? If this blew your mind, hit that like button and subscribe for more megastructures. And tell me in the comments which one I should cover next. Thanks for watching, and I'll see you in the next one.